Howdy, howdy, this is Mr. Potter. In this next unit, we're going to be stepping through Barbara Erickson's lab, the PictureLab, which basically is how we're going to manipulate pictures online through code using the data structures that we've talked about, using a lot of the inheritance concepts we've talked about. I need to introduce the concept of a color. So what I've got here is I've got a ColorChooser program. This is part of Miss Erickson's PictureLab. So we're going to go ahead and run this just to see what happens. And what this does is this brings up a ColorChooser object. This is part of the Java Swing classes, which is part of our graphical user interfaces, which we'll be talking a little bit more out throughout this lab. But what this does is this allows us to choose a color. So I have this option to choose colors based on, just what they look like, but I'm really interested in this tab here, which is my RGB values. Now, if you've ever looked at an old television or if you looked at an old computer monitor, you'll notice that you see groups of illuminated rectangles that are red, green, and blue in that order. And that's because when we're adding light, we can add red or green or blue to make virtually any color of light. What I'm doing in this particular example is I'm making full-on white, which means I'm adding a full intensity red, a full intensity green, and a full intensity blue. I'm not going to worry so much about the alpha because the alpha really deals with how transparent a particular color is, and it's not used in this project that we're going to be doing stuff with. But I am looking at the red, green, and blue consents. So what we're looking at is these red and green and blue values have full intensity, which goes from 0 to 255. You'll notice that that's 256 different possible numbers. So if I look at 2 to the 8th power, 2 to the 8th is 256. Remember that each bit is a 1 or a 0, so when I take 2 to the 8th, I'm talking about 256 bits, which makes 1 byte. So whenever I'm looking at a particular color, there's actually 3 bytes of data in it. 1 byte that deals with the red content, 1 byte that deals with the green content, and 1 byte that deals with the blue content. And so what I'm going to do is I'm going to go ahead and switch all of the green down to 0 and switch the blue down to 0. And notice that this gets me a full intensity red, which you can see here. And by the way, if you've ever done any HTML or if you've ever had to code, and you'll see the hexadecimal representation of 255, which is FF. Now, if I were to go ahead and take red light and green light and add them together, red and green actually make a very bright yellow. And so this yellow is the combination of red and green. This really is a secondary color when we're talking about light, when we're talking about additive. So if I were to take the green away and put the blue in instead, then I've got red plus blue, which makes this magenta color, this purple color. And similarly, if I were to take the red away and add the green, then if I add blue and green light together, I make this cyan light, this real light blue, almost a kind of a greenish blue light. But I can make a lot of different colors by just taking different values of these. Let's say if I was to take 127, which is about halfway to 255, and 127 again. Notice that adding a little bit of red, a little bit of green, and full intensity blue gets me this nice periwinkle color. And similarly, if I wanted to do something similar with red and half intensity green, half intensity blue, then I end up with this salmon color. And if I was to do the same thing with full intensity green and half intensity red and blue, then I end up with this nice seafoam green color. So I can make about 16 million colors, or 255 cubed, by just changing these values to different amounts. And something else that's important to note is that whenever I have all of them in equal amounts, I'll end up with something on the gray spectrum. So if I was to drop these to 127, 127, and 127, then you'll notice that I end up with this moderate gray. If I were to make these 192, then I end up with a much lighter gray. And if I bring those down to 64, 64, 64, and 64, I end up with this much darker gray. Of course, the absence of color is black, and so if I take everything away, then I'm left with just black. So the idea is that I can take different amounts of red, green, and blue and add them together in light to make lots of different colors. Now, I could just click somewhere on this spectrum and add a little bit more red to get whatever color that I would like. Notice the closer I am to this side over here, I basically am dealing with a 0, 0 coordinate over here and a 255, 255 coordinate over here, where red has this kind of spectrum from 0 to 255. If I go for something that doesn't have very much red in it, I could still get something that has red in it by choosing small values for my green and blue. If I want something that has a lot of red in it, I can even get things that look yellowish or kind of this light blue by just making sure my green and blue values are high as well. So it's this notion of being able to construct a color by adding different amounts of red, green, and blue. So what I want to do is I wanted to go to the color class. This is one of our classes that's in Java, so I've copied this from the source code. But the main idea is the notion of I have some static constants in here. So you notice the final white. White is 255, 255, 255. That's at full-on intensity for all of those colors. And I've got light gray, gray, dark gray, and black. And notice that in all of these situations, my red, green, and blue values are all the same, which is what we would expect. Similarly, I could look at different shades here. I've got red, which is full intensity red, no green, no blue. I've got pink down here, which is full intensity red and equal amounts of lighter, so this brings the shade up. It's adding more light to it. But because these are all equal, I'm still going to see more in the red spectrum here. If I add some green but not enough blue, then I end up with a fairly nice orange color, full intensity red, full intensity green together. Because we're adding light is going to give us a yellow color. And similarly, basically all the colors that I could think of in my Crayola box, I'm going to see as a constant in here with some level of red, green, and blue intensity. But I'm also interested in the constructor for this. So let me go ahead and scroll down to my color constructor. So notice what I've got here is my color constructor. I have red, green, and blue, the three parameters. And this is the constructor we're going to be using. This actually calls into another constructor which also deals with the alpha. But as I mentioned, we're not going to be using alpha. Alpha deals with transparency, which isn't really a part of this, because we're going to be looking at pictures, not moving animation where we'd want transparency behind it. So the alpha value is set at 255, which is full opacity, no transparency at all. So this is really what's important, is the idea that I'm going to be making a color by telling the red, green, and blue component of this. So we're going to be getting to this a little bit later. But I also wanted to talk about the concept of a pixel, because we are going to be making pictures out of this. And pixel stands for picture element. That's where the word pixel comes from. So for our pixel item, and this is part of your PictureExplorer, this is part of your PictureLab zip file. This is our thing here. Notice that it imports the color. So basically a pixel has to keep track of its color. But a pixel also needs to keep track of its X and Y coordinates, its column and row, and it also needs to keep track of the picture that it's from. Notice all of these are private, and so we're going to see later we're going to have accessors, we're going to have modifiers for these elements. So the constructor of a pixel is going to have three parameters to it. It needs to know the picture it's coming from, it needs to know the X and Y coordinates that it's coming from, the column and row. And it just basically initializes those instance variables. And of course we see get X, get Y, get row, get column, get alpha, which we're really not going to be dealing here. And then we also have get red, get green, and get blue. And what these are going to do is that they're going to get us the intensity of the red, the green, and the blue value at that particular pixel. And what this is doing is it's basically using some math using the hexadecimal to kind of force it to be from a 0 to 255 range, because there are some picture algorithms that instead of using 0 to 255 as integers will use 0 to 1 on the real number line spectrum. So you could have 0.24 or 24% red. And that's a little bit more intuitive for some people to see rather than just, oh, I have 196 red, which is approximately 3/4 intensity. So for our pixel, we're looking at basic accessors, get red, get green, get blue, in addition to get X and get Y, which gets us the row and column. And of course, I can get a color. So it's going to do the exact same things we were talking about with the red, green, and blue intensity. And it's going to return a new color object, which has the same red, green, and blue intensity as our pixel does. We can also set color. By giving a color, I can extract the red, the green, and the blue from it, and I can update a picture, which means changing that pixel's red, blue, and green color, doing that. So these are some of the methods that we're going to be using. But I really want to jump over to this PictureExplorer. Now, one thing I do want to mention is that this PictureExplorer is a huge program. It's about 800 lines long. Most of the program is actually setting up the graphics behind it, because setting up graphics program in Java can be a bit overhead heavy. But what's important for us to know is that we are going to have a picture that we're going to load along with rows and columns. And it's probably going to be better if I just go ahead and run this to show you what's going on. So let's go ahead and run this. So what I see here is a nice beach setting. You notice my row and my column are set to 0 and 0 respectively. So you'll see a little crosshair here that's at that 0, 0. And I notice that the red intensity is 2, the green intensity is 4, the blue intensity is 3. And so these are very low numbers on our 0 to 255 scale. And so I have something that's very dark. Notice, of course, that my green is a little bit more intense than the red and blue. And we probably would expect that for something that looks like it would be something of a tree. Heavy in shadow, of course, but it is a tree. But if I click on some other region here, like if I click over here into this part of the blue sky, you'll notice that blue is the most intense, as we'd expect. And because this is a lighter shade of blue, I'm expecting my red and my green to be pretty high values as well. If I click down here, I'm going to see that I'm in the sand, which is a yellow color. And we've noticed that yellow is really a combination of red and green. So I'm going to see that red and green are my most intense. But again, because this is a brighter shade, it's a lighter shade, very close to white, I'm going to see a high value for blue as well. If I were to click on these greens over here, let's go ahead and click this one over here, it's kind of in shadow, I should see that my green is actually fairly intense. I actually see a lot of red in here as well, which I wasn't really expecting. But again, all of these numbers are very low on that spectrum from 0 to 255, and so I would expect that to be a fairly dark color. And I can click on different regions of this picture. I can try and find some lighter leaves, like over here. I'll see I've got some pretty light leaves over here. Again, the highest, as I'd expect, is the green component. But because in nature, green really tends to be, on that transition green to brown to yellow, I do expect to see a little bit of red, not so much blue. Whenever I'm clicking in the water, I'm going to see a lot of blue. But again, here, seawater is kind of that bluish greenish color, so I see a lot of blues and greens. But what's really important for this lesson, for this idea, is the notion of what a color is and what a pixel is. Because what I'm doing is I'm clicking in individual pixels of this picture. And I'm extracting the red, the green, and the blue information from it. Okay, so here this mountain's fairly gray, so I expect all these values to be pretty close to each other. This is kind of a middle of the road gray, so I'm expecting all these to be in the middle, somewhere around 127, which is halfway to 255. And I'm going to see that for a lot of the grays that I've got here. For down here, these shadows, I'm going to expect to see very low numbers. Again, this is a very dark but pretty consistent gray, and all these numbers are pretty close to each other. So this notion of color, this notion of taking a look at color and being able to extract its red, green, and blue quantity, how intense it is in each of those colors, but also realizing that a picture is made of rows and columns of these pixel elements, these picture elements, that each have their own color is pretty important. Notice that I can increase along this, just increasing the column number, and I move horizontally across the picture, and I'm getting the new RGB values every time I go. So what I encourage you to do is to take a look at this. If you take a look in the Pictures folder, let me jump over to the Pictures folder here. Not the classes, but if I go to the PictureLab and go to the Images folder, I'm going to see a whole bunch of different pictures here. And what I can do is I can open these pictures up by going to the source code. Let me go ahead and close this real quick. But if I go to the source code, scroll down to the very, very, very bottom, and down here I see this picture gets new picture, and then in my parentheses I see beach.jpg. If I go over to my images, I can choose something else like kitten2. If I go over here and I change this to kitten2.jpg and I try and run this again, it's going to load this PictureExplorer up, but with my kitten. And so now what I can do is I can explore this kitten, some really nice yellows and pinks, and this beautiful blue, but the cat also allows us to explore some blacks and some whites. And so some really nice pictures in here to explore. And I do encourage you to change this last line of code to match the file name to either one of the pictures in this folder, or you can actually copy a picture from your electronic device and put it in this folder, and then you can explore your own pictures and see what your RGB color is. So once again, this is Mr. Potter. Thank you for watching. Have a great day.